Okay, hello everyone. We are now at Module 3. We will start with Lesson 3.1. Now, Lesson 3.1 will be about learning with the background knowledge that we need in order for us to construct the general solutions of homogeneous and non-homogeneous linear nth order differential equations. Okay, so we will start with the classification of linear differential equations, and then we will end with constructing the general solutions of homogeneous and non-homogeneous differential equations. Okay, so let's start with the classification. Okay, so we've already discussed in previous lessons how to identify if it is a differential equation is linear or not, and also the order. Okay, so in this lesson, we will focus on how to identify if it is homogeneous or non-homogeneous, and then if it has constant coefficients or variable coefficients. Okay, so let's take a look at the standard form, which is this one right here. So as you can see here, on the right side of the equation is a g of x. So this is a function of x, and this is sometimes this is referred to as a non-coefficient function. So it's called a non-coefficient function because if we take a look at the left-hand side, we have here a(n) of x up until a0 of x. So these are all um, coefficients, okay, of our function y and its derivatives. Okay, so let us start. For homogeneous linear differential equations, in order to identify those, we just take a look at the g of x. If g of x is equal to 0, so if this is equal to 0, then we can say that this is homogeneous. Okay, so if it is not equal to 0, then you can say that that is not a non-homogeneous linear differential equation. Okay, so that's how you identify homogeneity. So for constant coefficients, you take a look at the a(n) of x and all of the coefficients. Okay, and if these are constants, then we say our equation has constant coefficients, and if that is not the case, then we have variable coefficients. Okay, so let's proceed to some examples in order to clarify this classification. Okay, so let's start with the first one. So we have right here y double prime minus y is equal to 0. So first, let us ask ourselves if this is linear in the first place. So as you can see here, we have our coefficients. We have 1 and a negative 1 for y. Okay, so we can say that this is linear, right? And then after that, take a look at the order. So this is of the second order. And then if you go to the right-hand side of the equation, we have here 0. So this is our g of x, right? So if g of x is equal to 0, so what is this? This is homogeneous. Okay? So as you can see here, our coefficients on the left-hand side are all constants. So we can say that our equation has constant coefficients. Okay, so that is basically it. So let's do some more examples. For number 2, we have here y prime plus 2y plus 3 is equal to 0. Now, if we take a look at this carefully, this is actually not in the standard form. Because if you take a look at our standard form, the function y has the coefficient a0 of x, and our first derivative has the coefficient a2 of x, right? So if you go back to our given equation, we have right here, our y prime already has the coefficient of 1, right? And our y function already has the coefficient of positive 2. Now this positive 3 right here actually is our non-coefficient function, so we just have to transfer it to the right side in order to convert this to the standard form. Okay, so let's subtract 3 from both sides of the equation, so we will get y prime plus 2y is equal to negative 3. Okay, so now let us start classifying this. So we can say that this is linear, right? And then the order, it is first order. First order. And then since our right-hand side of the equation is not equal to 0, this is non-homogeneous, right? Okay, and then we also have, since the coefficients on the left-hand side are 1 and positive 2, then we have constant coefficients. Okay, so now let's proceed to the third example. Okay, so let's just erase some of these examples so you can see the given. Please wait a second while I erase this. Okay, so now we have some space. Let's proceed to the third one. So we have here um, dx to the fourth plus y to the fourth is equal to 0. Okay, so as you can see here, we have here the fourth order, and this is non-linear, right? So because of this y to the fourth, so this is non-linear. So the fact that this is non-linear, so we cannot proceed with the classification. Okay, so that is our answer for that particular example. Okay, so now let us proceed now to the fourth one. So 2e raised to the x, y to the third order, and then plus e raised to x, y double prime is equal to 1. So as you can see here, this is definitely linear. And so let's classify that as linear. And it is of the third order, right? Because of this. So third order. And then the right hand side is not 0. So this is non-homogeneous. And then for the last one, let's see the coefficients on the left hand side. So these are not constants. So we say that we have variable coefficients. Okay, so that's it for the classification of linear differential equations of the nth order. And yeah, so in the next lesson, we will proceed with the existence and uniqueness theorem. Okay, so thank you for watching, and I hope you learned something, and see you in the next videos.